All right, we're going to start our next section. This section from what follows. And to begin with, we got a little bit of theory on the notation here, sigma notation. So our goal in this chapter, our main goal, is to take a function, random function, and find the area between two verticals in the x-axis. That's our main goal in this section. Everything we do is to that end, so we're going to build up to that. Okay, now, so one of the tools we need is the sigma notation. We're going to be using this extensively. So here it is. I've just given a definition, and it really doesn't need much of an explanation. It's shorthand for a big sum from I equal 1 through n. I is the index of summation. And we have some special formulas that come out of that using that notation. The sum of a constant from 1 to n is Cn. Sum of I, that's 1 plus 2 plus 3 plus 4 plus 5, is n times n plus 1 over 2. I squared has a similar formula. We're not going to prove these. The first couple are easy enough to see, but this next one, it might not be so obvious actually where the formula came from, but we're going to use it anyway. And same thing with I cubed. So we're not going to go into the proofs of any of that or even the derivations of any of those. We're just going to use them. And we'll do that in our first example here. I'll show you a couple ways to do this. I'll do this in this first video. I'm going to do the derivation of a general form for this, a formula involving n. And then we'll show what you can do with a calculator for that in a subsequent video. So this will be a quick one here, so as fast as we can do it. So we'll start off. You notice in here, you have an n. That n is independent because the index of summation involves I equals 1 through n. So really, you just have this. And that can be broken up this way. You have a sum from 1 through n of the number 2 plus the sum from I equals 1 through n of I. And that's 1 over n. This first sum is just 2n. That's using our first summation formula of a constant, sum of a constant. And then the second formula is the n times n plus 1 over 2. That's the sum of I. Now, if you distribute this 1 over n, you'll get this. If you want to write that as a single fraction, you'll have 4 plus n plus 1 over 2, which is n plus 5 over 2. So there's your formula. We can call it S of n, a sum of n. So for this thing here, this is S of n. It's a function of n. So when we go to compute n s at n equals 10, we just take s of 10, throw it into our formula. We'll have 10 plus 5 over 2, which is 7.5. If you want s of 1,000, you'll take 1,000 plus 5 over 2, which is 1,005 over 2, and that's what, 502.5. So we'll put a little work up front here with the algebra, but the payoff was in calculating the sum for a large value of n. You wouldn't want to do that by expanding this sum. So this is the power of the formulas that really is what we're interested in here, is how these formulas can be useful for us and save time. So that's that's the practical aspect. In the next video, I'm going to show you how to get some of these sums on the calculator. So we can do a little bit of this on the calculator.